Now guys, just going to give a look here then. This is also, just adjust this camera in a little bit. Okay, so this question here, very clever question, because this is the plan of the base of a square base pyramid. Now I cannot emphasize enough the importance of one word here, which is that it's a square base pyramid. Okay, so now it further goes on to say then that it's inclined in such a way that only the edge BC is on the ground. Okay, so BC is on the ground. So like really what's happening here, if I had room to draw it, is that this is a pyramid. Okay, so this is a pyramid and we can only see some of the sides, and here is the ground. But it's only BC, oh, that's C, and that's B. So this is lifted up off the ground. So if it was, it's not sitting on the ground. If it was sitting on the ground, it would be way down here. Okay, that's where the base would have been. But it's tilted and it's lifted up, hinging along CB. So the word square is a key word to understand there. And if I measure this, that is 44 millimeters. So this C to D, the real length is 44 as well, but it appears less because of the tilt in it. So that there is very, very important to understand that. So they've already set up here for us the auxiliary here. So I'm going to project up here at this angle. So that's C and B and A and D. But we know that CB are the two that's on the ground. But again, now I refer back to what I was saying, that the importance of that word square, that this distance here of, I think I said it was 44, that has to be the distance over to D and A as well. So if I just measure this and step that out there and say that's 44, well this has to be 44 as well. And we now have the height up off the ground. So I could go and draw the base now in the front view if I wanted, because the elevation, should I say, because both D and A are up off the ground. That is D and A. So now we know that they are, if I was to measure it with a set square, we know that they are 31-ish, but I prefer a compass. That's how high they are above the horizontal plane. So just step both of them up there. And just project up there that C is on the ground, B is on the ground, and there's B, there's C, C joins to D, D goes along to A. I'm going to just draw that light for the time being, and so there's A up here, and A goes to B. Just going to leave that light for the time being as well. So that's the base now with D and A lifted up in the air, and all of that was kind of deduced from the fact that if it's a square, C to B is the same difference as C to D. Now, so complete the planned elevation of the solid, because they told them that the solid has an altitude of 45 millimeters. So again, and this comes back to basic square base pyramids. If I guess to do it properly now, I should be bisecting this angle here, or bisecting this line here, I should say. So just bisect that line, which is the base. And we were told there then that the altitude was 45. Square base pyramid, altitude 45. So that there is O. Now the altitude of the pyramid is 45, but its actual altitude above the ground, I'm going to want it here. So that's the altitude above the ground. Very different to the altitude of the pyramid as such, because that's if it was sitting all completely on the ground. So that's the height of my apex O, and I'm going to use that in a second. I'll just swing up an arc here and just go parallel to our tangent to the top of that arc. So that's going to be the height of this. So if I project this now back down, so that's the angle that I looked up here. So when I project that back down, that apex comes down here. And again there, now one other thing that you would be expected to know is that if I cross the corners here light, that is where the apex of the pyramid would be. Or that's the plane going through the center of the pyramid. So the further I tilt that out, the apex has to be on a plane basically passing through the middle of the pyramid. So we know that there's O, so there's the top of the pyramid. So I'm going to just join that lightly for now, back down to the four corners. And then I'm going to project that apex O to the elevation, and it just comes in here underneath the auxiliary. So that's O, and there are all my edges going up to that. Now I did read the question fully earlier on, always something to be recommended, and that's kind of why I'm leaving all these light, because they said to complete the plan, the elevation of the solid, and that when resting with its base on the horizontal plane, the top of the solid was horizontally cut at a height of 25. So basically they're saying that this pyramid, top of it gets chopped off 25 above the ground when it's sitting on the ground. So 25 above the ground would be here, and if it was chopped 25 above the ground when it's sitting on the ground, it basically means parallel to the base. So the rest of that is chopped off. So I'll just heavy that in. I would like to rub out the rest of it, but I need to find my rubber. Okay, so the rest of that there, just lighten that out. But I will leave that there. I'll just kind of do it like this. That's where the top of it would have been, because we did need that for the construction, because we used that to bring it down to find where the plan is here. So now I just need to project that information back. Let's try to leave in a bit more light here. So I want to project this information back. Okay, so C and B are cut here. Just project that down, C and B. And then A and D going to the top of the pyramid are cut here. So I'll just heavy these in now. So A to D. And I'm going to there now, just rub out to lighten off. Okay, so just lighten off the base here now, because CB is on the ground, and here is where, like, if you imagine a person up here in the air looking down on top of this, they're going to see AD heavy, and they're going to see that short AD edge here where they're cut, and they're going to see where CB gets cut, but what they won't see is the full edge CB down on the ground. That is going to be hidden down here. So oh yeah, I actually can't lighten that off because it was the original drawing on the book, but that wasn't the greatest of foresight. But anyway, so I'll just heavy these in. And I might just put a tiny bit of colour on that cut section here, just to try and make it easier to visualize. Okay, so that cut section is along there. And my next move now is I just need to project these up to the elevation. Now there's a couple of ways I could do this. I could take heights from over here vertically off the ground, but I think I'll just project so the D O line, or D going to the top, is cut here, and the A line is cut at the same height as that then. So I could just draw this across here. And then OC line is cut here, and I'll bring that up O to C. So that would be here, and that's also the same height as O to B. So when I'm looking in from the front, I will see, because here's the plan here, so I'm going to see the C and the D line are definitely going to be visible. Okay, so I'll just heavy in the rest of this. Now what I can't see heavy here then is A going to D and A going to B. So I'm going to just dot these in. just touch a bit of colour on the top of this as well. Now you may not have time for doing this in an exam, but I always recommend doing it when you're doing a question, because it will just make it so much easier to visualize and to see these things. So there's our cut surface, and the last thing they wanted here now was the true shape of the cut surface. Draw the true shape of the cut surface. So again, there's a few different ways that I could do that, based on the fact that this is a horizontal line here. I could rebat it over here, or I could take an auxiliary off of here, but really, because it's a square base pyramid that's cut horizontal, there's so many different ways. I think that is probably the easiest way. If I just measure this here, I'm getting that that's 20. So basically the true shape of that is just a square of 20. So it would be as simple as just drawing somewhere out here a square of 20 and calling it the true shape. TS for true shape. So that's kind of done by what I would call transferring distances, or you could do it by rebatment, or if I had just measured that there, because we know that this is a square, so you could just swing that. If you wanted to just attach it onto part of the drawing, I could have swung that up there and just rebatted this up and over, and that would give me a true shape here. Just say there TS as well, but I'm not going to heavy that in now because it would be a bit of distraction from the other things. So I'll just lightly put it in there and color that in there, that's the true shape as well. But again, because it was, I would prefer this first one there, where you just transfer the distances and take it off the drawing, because it doesn't take from the rest of the drawing. But again there, if you understood that the true shape is a square and that that's the edge view of a square, so all you needed was this distance here, which is 20, and take that out there. So yeah, really good question. There's a lot in this, an awful lot in this question. So I hope you enjoy doing that.